Greetings once again and welcome to Edu-ca-te. If we had pre-watched our previous video on the introduction to vectors and scalars, you are at the right place. But then if you haven't watched it, please consider watching that first, because that will give you more clarity as to exactly where I will leading to in this video today. Stay tuned. So today we're going to be talking about the addition of vectors in one dimension. Okay, so one-dimensional vector diagrams are the easiest ones to solve, as it says there. So they're just only one dimension, so it means that it's just only one perspective of it. So it's one-dimensional vectors. Those are the ones which we were doing last time. So it continues and says that we refer to vectors that line up with each other as collinear, together linear vectors. So the only thing you have to really watch out for is how you touch the vectors to each other in the diagram. So to add vectors, the vectors must touch with the head of one, the pointy tip touching the tail, nothing else. Now, nothing there of the vector. So here, how do you add vectors? So supposedly you've been given two vectors. You've been given vector 1, let me name it v1, and you've been given v2. So how do you add these vectors? So it's simple to add them. You just have to make sure that the head of these other vectors, the head of this vector 1 must collide with this head of vector number 2. So if you are going to draw a combined vector diagram of them, you're just going to represent the tail of vector number 1 going there, and then the tail of vector number 2 going there. That is all. You don't have it becomes wrong when you're given vectors like this with their directions and stuff, and then you decide to make the heads to collide in this way. It becomes wrong. It's because we are given the very same direction here. The direction of these vectors are going that side. So that means that you have added these vectors. Therefore, we come to this concept of the resultant vector. What is exactly the resultant vector? So basically, the resultant vector talks about this vector which is as a result. So it says resultant. Resultant just simply means as a result of something. So the result at the beginning, it means a result of something. So this is the resultant vector. So the resultant vector is actually the vector that is as a result of the addition or the combination of certain vectors. So in this way, supposedly you are given a direction. They say a boy walks 50 kilometers to the school, and 70 kilometers to the store, and then calculate his resultant, let's say, just say calculate his resultant. So here you're given a statement that involves two vectors. So it says a boy walks 50 kilometers to the school and then 70 kilometers to the store. So here you have got two locations in which this boy is going. So supposedly here, let me just be general. Here is this boy here at an initial point, at a starting point or an initial point, is the same thing. And then that boy moves here. Right, supposedly this is his house. Here is his house. Right, and then he moves to where? To the school. This is your school, although it's so small. So he moves to where? To the school, and then goes to where? To the store. This is the store. So here, let's just try to name what we have. We've got home, school, store. So these are the two locations this boy is going through. So first is coming from home, so this is the tail. Remember when we discussed in a vector that the tail is the starting point or wherever this boy started. So he moved to that direction, although I didn't indicate the direction in the statement, but then he walks 50 kilometers to school. 50 kilometers. So the magnitude of this first vector is 50 kilometers. Let's name it F1. So that's your first vector. And then your second vector, F2, he's moving 70 kilometers. Don't mind the length of the vectors, but then it's just representing them. Okay, so it's 70 kilometers. It moves from home to school in an easterly direction, 50 kilometers. So it goes to the east, 50 kilometers, and goes to the store east. That very same direction is 70 kilometers. So we call these points collinear. Collinear. So it means the home, the school, and the store in total, they are all collinear points. What do we mean when they say they are all collinear? They can be in, we can just generally say it's in a same line. It's in a same line. There are points on the same line. So if we were going to draw vectors for this, we have got three vectors. We've got actually two vectors, okay, from home to school and from school to the store. So how do we represent these vectors? We're gonna start here at the starting point, which is home here. This is the tail of the vector, and then moves 50 kilometers to school. So this is the magnitude of this first vector, or the size of the distance of the first vector. And then from this point, it moves here to the store. So we have already combined these two vectors and moves 70 kilometers. Let me just increase the size here. So he moves 70 kilometers to another point. So it means started at this point, point H, which is the home, school, and store. You see, so we have got 3 points here which are collinear. Point number 1, H. Point number 2, S. Point number 3, ST. Therefore, we have to calculate his resultant vector. So how are you going to calculate the resultant vector? Remember, the resultant vector has to do with the result. Here we have been given his distance. That is the magnitude we have been given in these vectors. His distance, which is 50 kilometers, 70 kilometers, respectively. Therefore, you have to do the resultant. The resultant starts from the starting point to the ending point. So you simply have to look and say, determine what is your starting point, what is your ending point. So your starting point was home. So you will have this vector here. That's the tail. Your ending point was this point. You draw your head and then you make sure that these meet in this way. And then now you have your resultant vector. So this is your FR. So it means the resultant vector, whenever you hear the word resultant vector, it starts from the starting point or the tail or wherever you started up to the ending point. So this is one dimension. These are collinear points. Therefore, if they were to say calculate the magnitude of the resultant vector or what is the size of the resultant vector, you were going to say F net is equal to F1 plus F2. Why are you adding these two? Is because these two make up this F net, which is the resultant vector. So if you are going to add these two, you are going to take 50 kilometers from the first vector and 70 kilometers from the second vector. You add them together to form a result. So this vector FR is as a result of 50 kilometers and 70 kilometers. Therefore, you have to add them in this way. So this is the algebraic representation of the F net. So F1, we had 50 kilometers. F1, it just means this first vector. Let's just label them F1 and F2. So we've got F1 plus F2, which is equal to 50 plus 70 kilometers. So this is the resultant in terms of distance. So 50 plus 70 is equal to 120. So this is 120. That's your resultant vector. And then you're just not going to write 120 and that's all. You have to write the units. The units, remember the SI units help you to determine or to identify what are you talking about. You cannot just come and say 20 or 120. How will we understand exactly what are you talking about? You have to tell exactly what are you talking about. If you're talking about calculators, say 120 calculators, 120 school children, 120 whatever. So in this case, the unit is kilometers. So the resultant force is 120 kilometers. You represent it as F net. That is how you add vectors in collinear points. Thank you for watching. Stay tuned for the next video.